Returning to the Arctic region, I want to point your attention to that area, a submerged shelf off of Siberia that is approximately 70 meters, about 200 feet below water. During ice ages past, it was above water, and there was abundant life there at times. And now that life is decomposed under the sediments of that East Siberian Arctic shelf and has turned into something else. Here's another view, a map view of the East Siberian Arctic shelf. And as you'll read the caption, it says that that shallow ledge of submerged sea shelf is estimated to contain between 500 and 5,000 gigatons, billion tons of methane, a huge amount. To give you a sense of the magnitude, there are approximately 5 gigatons of methane in the atmosphere of Earth today. And we are talking about from hundreds to thousands of times that amount contained in that one shallow ledge. What you're seeing on this slide is the release of methane from one of several hundred plumes that were discovered when explorations went up there in 2007. And the notation that methane is approximately 86 times as powerful a greenhouse gas as CO2. Now, you will see variation in that number for the following reason. When the methane is emitted, it's estimated to be above 150 times as powerful a greenhouse gas as CO2. Over 150 times as powerful. However, the methane begins to decay when it's exposed to air, and it becomes H2O and CO2. So it decays to a less impactful form of a greenhouse gas, carbon dioxide, but it does so slowly. So the 86 number is the number I've seen over a 20-year period. That number is represented as approximately 23 over a 100-year period. That is, during the first year, it's extremely dangerous, and it becomes less dangerous over time. Now, watch the methane.
Oh my God. Here? On the side, yeah. Right here. Oh, whoa!
Thank you. Those were students in Alaska whose teacher had brought them out on a frozen lake, because it happens in lakes as well. The sediments of the lake, which contain organic material, the organic material, when it's digested in an anaerobic environment, becomes methane instead of CO2. And so kids have found that it's fun to go and poke holes in the ice and light that on fire. It's kind of Arctic fireworks.
So for the last 2 or 3 years, there's been a joint Russian-Alaskan expedition going out into the Siberian Sea and observing this, and they've been seeing great plumes of methane bubbling up all over the East Siberian Sea. The whole zone of millions of square miles of territory is now releasing all of its methane cover.
Dr. Natalia Shakova leads a team of scientists, joint American-Russian scientific team, studying conditions on the East Siberian Arctic shelf. Here are her words.
So the methane in the atmosphere, the total amount of methane in the atmosphere, in the current atmosphere, it's about 5 gigatons. The amount of carbon preserved in form of methane in this Siberian Arctic shelf is approximately from hundreds to thousands of gigatons. And of course, it's only 1% of that amount is required to double the atmospheric burden of methane. But to destabilize 1% of this carbon pool, I think it's not much effort needed, considering that the state of permafrost and the amount of methane currently involved.
And one more remark from Dr. Shakova.
The worst thing might happen. Shortly speaking, we do not like what we see there. Absolutely do not like.
Well, here's a sobering thought. Methane levels in the atmosphere surged last year, despite the pandemic. Now, NOAA says it was the biggest annual jump since record-keeping started back in the early 1980s. Scientists found that rise pretty surprising and disturbing. You see, methane packs a really powerful punch when it comes to global warming. It's 28 times more potent than CO2 at trapping heat over a 100-year period. The main drivers of methane emissions are oil and gas production and agriculture. But scientists say that Arctic permafrost could also play a role. As the world warms and permafrost melts, it releases methane into the atmosphere. And that, of course, leads to even more warming and more melting and kind of this vicious feedback loop. NOAA's measurements come from weekly air samples collected from about 40 sites around the world.
Well, good evening, friends, and welcome to Environmental Coffee House. I am, as usual.
Absolutely.
Let's get back.
So, the Global Monitoring Laboratory makes highly accurate measurements of the three major greenhouse gases, carbon dioxide, methane, nitrous oxide, from 4 baseline observations in Hawaii, Alaska, American Samoa, and the South Pole. So they take measurements everywhere. These samples are collected by volunteers at more than 50 other cooperative sampling sites around the world. So basically, the point is, it's not just happening in this one place.
Right.
It's happening around the entire globe. The entire globe. So here's the interesting part. Methane levels also surged, and I hope that Nostradamus will enlighten us about these things.
Yeah, I have to
And
see
now
who's in the audience.
I hope so. Analysis of samples from 2020 also showed a significant jump in the atmospheric burden of methane, which is far less abundant, but 28 times more potent than CO2 at trapping heat over a 100-year time frame. Everybody here on this call knows about this, right?
Yeah.
NOAA's preliminary analysis showed the annual increase in atmospheric methane for 2020 was 14.7 parts per billion more. Now, that doesn't sound like very much, right? But you have to remember that methane's measured in parts per billion, and we're up at around, what is it now, 1850, 1870 parts per billion on average of methane. So methane is very, very small, but very, very potent. Small. Very, very tiny, very, very potent.
Yep. Which
is the largest, and the other problem, you got to look at the trends, right? You got to look at the trends. So it went up 14.7 parts per billion this year.
Yeah, I've got a graphic if you want me to show it.
Yeah,
I have
please.
the CH4 graphic, the monthly means,
Dynamite.
And it shows.
Dynamite.
Everybody can check that out. It's from this website, and it shows the differences, and there's a whole explanation on the dots. But we're going to wait for Nostradamus, unless, Jen, you want to tackle this one. We're going with the article.
Well, this is good. I mean, I can take you through the basics. Nostradamus can take you through what's happening right now. Yeah. But, I mean, just look at the shape of this methane graph. It's a little bit like, look at the one that's over on the right-hand side. That's the one that's running from 1958, the last 63 years, to 2021. And the problem is, like, it did kind of level out there for a while. And then right around 2000, it was off to the races. And you got to just look at the shape of the curve. Now, if you want to take a detailed look at the shape of the curve, look at the graphic on the left. That's the one that is the percent of global monthly CH4 methane. And look at the shape. See how it's got a little, it's not like a straight line. It's got a little indent. That's the thing that you have to keep your eye on. How is this thing shaped? See, look, what bothers me about this is if you look at the graphic on the right towards the end of that, see the steepness of that curve, where it hits 2021?
Yes. Yes.
So it's like it's starting to go up like.
I'm going to put up your graph. And can you see it? Can everybody see it?
Bad earlier.
All right. Why don't you have a whirl and tell us about it?
I'm just comparing the very latest figures, as reported on the NOAA website by the 2 satellites in orbit, to the exact same date 2 years ago, which is when just after I started recording the data, to see how much it's changed since. And this is at the 300 millibar height, where most of it collects in the atmosphere, where it's at its thickest, where it rises up to. And as you can see, it's gone up 44 parts per billion in 2 years. But last year it only went up about 10, and this year it's about 30 parts per billion higher than last year. So it seems to be accelerating.
It looks to me, looking at this, so you've got a mean of 1858 in 2019, and then
That's an average of
2021, you've got a mean of 1902. So that's a difference of 50 in 2 years. So it's not going up 14 parts per billion a year. It's going up 25 parts per billion, right? Or no, or is it 40? Oh, it's 40. So it's going up 20 parts per billion a year on average. Is that correct?
22. It's gone up 44 parts per billion in 24 months at that particular altitude.
That's so. What do you attribute this sudden rise in methane to, or
I
this
think most of
increasing rise?
I think most of it's coming out the ground, and it's not coming up in one go, but it's just steadily increasing.
So do you feel that it's coming out of permafrost?
Yeah, definitely.